Hello students and welcome back to my channel. I'm once again here continuing with the previous video, that is first video. This is in continuation with that second video. Questions have been picked from 30th January 2023 JEE mains exam. Okay, both morning and evening shifts have been combined here. You can see the properly, morning or evening session has been mentioned alongside the question. You can see. Right. So without wasting time, let us start discussing. The figure represents momentum versus time curve. For a particle moving along x-axis under the influence of the force, identify the regions on the graph where the magnitude of the force is maximum and minimum. Now, students, as you know, Newton's second law states that force is simply is equal to, in SI unit, rate of change of momentum. Okay, in SI unit, it is equal to rate of change of momentum. So basically, dp by dt will be given by the slope of the p versus time curve. You know from maths, for any function y equal to f of x, dy by dx represents the slope. So here also dp by dt will be the slope, and slope is a measure of the steepness. So in order to have maximum force, the steepness should be maximum. Here we can see the steepness is maximum for the C part. In this part, steepness is maximum. Whereas for minimum force, steepness should be minimum, and you can see B part steepness is minimum. So C and B respectively. Maximum at C and minimum at B. Moving on to the next question. As per the given figure, a small ball P slides on the quadrant of a circle and hits the other ball Q of equal mass, which is initially at rest, neglecting the effect of friction and assuming the collision to be elastic. Collision is elastic. The velocity of ball Q after collision will be. Now it's a matter of simple fact, students. You know, when two equal masses undergo elastic collision, their velocities get exchanged after collision. This is a simple fact you must be knowing. Again, I'll repeat. When two bodies of equal masses, smooth bodies of course, undergo elastic collision, perfectly elastic collision, then their velocities get interchanged after the collision. So that means what will be the velocity gained by particle P just before collision, that will be imparted to Q, and Q will come out with that velocity. In other words, we have to find the velocity acquired by P just before it strikes Q. Now for smooth surfaces, the velocity acquired is always given by under root 2 gh, to root 2 gh, because this formula can be directly obtained from law of conservation of mechanical energy. When you equate the loss in gravitational potential energy with gain in kinetic energy, you get this equation. So initially P was here, and just before it strikes Q it is here. So loss in height is h. So that is 20 centimeter, which is the radius. So you get the answer. So 2 g is given as 10 meters per second square. Height is 20 centimeter. Divide by 100 to convert it into meter. So two zeros gets cancelled. Root 4 is 2. So P acquires a velocity equal to 2 meters per second, which imparts, which it donates its velocity, or it imparts its velocity to Q. So Q comes out with the velocity 2 meters per second after collision. Moving on to the next question. Sorry. A ball of mass 200 gram rests on a vertical post of height 20 meters. A bullet of mass 10 gram traveling in horizontal direction hits the center of the ball. After collision, both travel independently. The ball hits the ground at a distance 30 meters and the bullet at a distance 120 meters from the foot of the post. The value of initial velocity of the bullet will be. Right. A simple diagram will clarify everything. Okay. So this is let us say this is the post. Okay, post is 20 meters high. It is given 20 meters high, and there's a ball here and a bullet. After collision, it is given that the ball hits at a distance of 30 meters from the foot of the post, whereas the bullet is 120 meters away from the foot of the post. So we have to find the initial velocity. Initial velocity u we have to find, right? So here we can find the velocities with which the ball and the bullet came out after collision. Velocity of the ball, let us say v1, velocity of bullet, let us say it is v2. So we can easily find the velocities based on this information. Now you see students, initially, immediately after the collision, there was no initial velocity in the vertical direction, and it has to undergo a displacement of 20 meters in the vertical direction before the ball or the bullet touches the ground. Is it? So we can find the time taken by the ball or the bullet to reach the ground. In other words, time taken by the bullet to fall freely through a height of 20 meters with initial speed 0. So time can be obtained as under root 2h by g, or you can use s equal to ut plus half at square where u is 0. So h is 20 meters, g is 10. So root 4 is 2 seconds. So time of fall is 2 seconds. Now students, you see, during these 2 seconds, the ball traveled a distance 30 meters. So certainly velocity of the ball must be how much? If distance traveled is 30 meters in time 2 seconds, then velocity of the ball is 15 meters per second. Similarly, the bullet travels a distance 120 meters in 2 seconds, then the velocity of bullet is 120 meters upon 2 seconds, that is 60 meters per second. So once you know their final velocities, it's a matter of what? Applying law of conservation of linear momentum before the collision and immediately after the collision. Okay? Just before the collision, immediately after the collision. So here itself, we'll see. So this is the bullet, this is the ball, and after collision, it is like this. So law of conservation of momentum. If you apply law of conservation of momentum, then you have initial momentum is equal to final momentum of the system. Initial momentum is only the bullet has the momentum initially. There is no momentum of the ball because the ball rests, okay, on the at the top of the pole. Whereas for momentum after the collision, you have this. So mass of the bullet is 10 gram. So 10 gram initial velocity we have to find. Remember, we are putting masses in grams, so no need to convert it into kilogram because on both sides the conversion factor will anyway get cancelled. Okay, so V2 is 60 and this is 200 gram, V1 is 15. Let us cancel 1 0 throughout. So U is equal to 60 plus 300, that is 360 meters per second. Correct option is the D option, that is fourth option. Then moving on to the next question. A machine gun of mass 10 kg fires 20 gram bullets at the rate of 180 bullets per minute with a speed of 100 meters per second each. The required velocity of the gun is. So this is a slightly tricky question, student, where we have to consider the situation for 1 second. That is for unit time interval, 1 second. Just see what happens in 1 second. So this is the gun. Kindly forgive me for the diagram I am drawing. It is not a machine gun, but just to manage. We'll manage with this diagram itself. Okay. Now, in 1 second, what will be the number of bullets emitted? You have to consider all the bullets together as a single body. Then our problem is solved. So we are considering in 1 second. You can see 180 bullets are fired in 1 minute, that is 60 seconds. So 180 bullets in 60 seconds means 3 bullets per second. 3 bullets per second. Now each bullet has a mass 20 gram. So considering all the 3 bullets together as a single body, their mass will be 20 gram into 3, that is 60 grams. Okay. So now we'll apply the law of conservation of momentum. Because as you know, whenever you come across the word recoil velocity, the only formula applicable is the law of conservation of linear momentum. So law of conservation of linear momentum states that initial momentum must be equal to final momentum. Initially both the things were at rest, isn't it? The gun as well as the bullets. So final momentum is for the gun, it is 10 kg mass and velocity we have to find. Whereas for the bullets, mass is 60 gram. Remember, gram has to be converted into kg by dividing the 1000, and velocity is 100 meters per second. Okay. So here we can cancel whatever gets cancelled here. So 3 zeros gets cancelled here. So 10V is equal to minus 6. So V is equal to minus 6 by 10, that is minus 0.06 meter per second. The minus indicates that it is a recoil velocity, okay? Because it moves opposite to the direction in which bullets are being coming out. Bullets are coming out in the forward direction, so automatically the gun will recoil in the backward direction. So because of that backward direction, you have minus sign. Moving on to the next question. A block of 3 kg is attached to a string. Sorry, it's root 3 kg, I'm sorry. Is attached to a string whose other end is attached to the wall. An unknown force F is applied so that string makes an angle of 30 degree with the ball. Tension in the. Now students, a simple thing you have to remember. Whenever a point or a body is under the influence of three coplanar forces, you can always draw the force triangle. Particularly if two of the forces are at right angles, this will be very, very helpful and very easy to solve. Draw the force triangle because you must get a triangle because the body is in equilibrium under the influence of three forces. The concept of equilibrium states that when a body or a point is under the equilibrium of any number of forces, when you draw all the forces in direction and magnitude, you get a closed polygon. In case of three forces, it will be a three-sided polygon which is a triangle. So let us draw. So this is tension. So you can see this triangle. I'll pick this triangle itself. Okay. So this triangle will help us. So this is tension here, and this is root 3 into G. G is 10, and this is F. We were not bothered of F. So this angle is 30 degrees. So this is 30 degrees. So we'll be using this, the trigonometric ratio which involves based on 30 degree, which involves hypotenuse and base, is cos. So we can write cos 30 degree is equal to base upon hypotenuse, and cos 30 is root 3 by 2. So therefore root 3 gets cancelled. So T is equal to 20 Newton. So C option is the correct option. Moving on to the next question. Question 12. Body of mass 2 kg initially at rest, it starts moving unidirectionally. Uni means single, in a single direction, under the influence of a source of constant power T. Its displacement in 4 seconds is this. Remember, we have to proceed in SI units. Okay? So the moment a force acts, the body acquires energy because the force keeps doing work. Okay? What will be the source of power? power as it delivers the power. Work is being done on the mechanical work is done on the object, and accordingly it acquires kinetic energy. So from work energy theorem we can say, or law of conservation of energy for that matter, we can say that total work done on the body results in change in kinetic energy. Change in kinetic energy. So work done over a time t is p into t. Since p is constant, so simply multiply power with t. Okay, and change in kinetic energy is half m v square minus u square, where u is the initial velocity which is 0 and v is the final velocity. So since u is 0, I can write this as like this. Okay, remember we have to find displacement. Now our aim is to express displacement as a function of time so that we can put the required time here and we'll get the answer. Okay, so from this result we can write v is equal to root 2 pt by m, root 2 pt by m. This is velocity, which is also equal to ds by dt. Okay, so this is a variable separable differential equation. So accordingly we have this separating the variables. You know how to solve variable separable differential equations. After separating the variables to the two sides of the equation, integrate both sides. Okay, integrating both sides. Now initially the body was at rest, so there was no displacement at all. So displacement is 0. And finally we require the displacement as, here the corresponding values, initially time was 0 and finally the time is 4 seconds. It's given. So just integrate this to get the value of s. So under root 2 p m is also 2, t power half, integral t power half is t power 3 by 2. So t to the power 3 by 2 upon 3 by 2, integrated with limit 0 to 4. So root p remains as it is. Then you have 2 by 3. When you substitute upper limit, 4 power 3 by 2. 4 power half is 2. 2 cube is 8 minus 0. So you have alpha square is 16, as you can see. So alpha square is 16. So alpha is 4. So 4 is the correct answer. Moving on to the next question. I think all are over. Yes, that's all students in this video. Thank you so much for watching. If you like my channel, kindly subscribe to it to get more videos like this and also hit the like button. Thank you so much.